Shutesbury has an interesting community makeup. It has changed dramatically over the last 10 years. For a long time, it was a school of about 85 students. It has more than doubled in size. This was primarily a rural working-class town and was discovered by people from Amherst, predominantly people from the university and people who had professional positions. And now we have about 230 students.
Everyone translation?
Yeah.
We really, throughout the school, have a belief and a commitment to having in-depth studies where students really take on the role of people who become immersed in a subject and ask deeper questions and learn how interconnected things are because they become deeply immersed in a study.
I'm Ron Berger, and I am one of 3 5th and 6th grade teachers here at Shutesbury Elementary School. Our curriculum is not a set curriculum. We're a one-school district, and so we as a staff shape our own curriculum. And we tend to handcraft our curriculum. My classroom is thematic. That means that I'm choosing one theme. This fall my theme has been water, and trying to work into that theme the kinds of science understandings, math understandings, and language arts skills and concepts that I'd like to all within the theme of water.
We wanted to see if water in general was safe in Shutesbury because we all have private wells, and most people have never had their water tested, so they don't really know whether their water is safe or not. So as a community service, we were going to test the water.
Ron's students gathered water samples from 63 wells across the town. At each site, sample A consisted of water that had remained static inside the pipes for at least 8 hours, while sample B consisted of water that was taken after the tap had been running for 5 minutes. These samples were analyzed for pH and for heavy metals by students at nearby Hampshire College under a grant from the Massachusetts Department of Education.
I'm not an expert on water, so to build this unit I had to go to a number of different college professors and people whose professional work was in water science to get the information I needed to construct the unit.
Now this guy's dead. Okay. We took the sample A and B's for copper. If we see like a line up there, you'd see that there is a relation because it would keep going up like that or something like this. But this doesn't have one.
We worked out a partnership with Hampshire College through Professor John Reed, where his science students at the college and our elementary students would work together to do this analysis. We got access to a mass spectrometer, and through a grant from the Department of Education, we were able to run that machine down at Hampshire College and do a full spectral analysis of water here for inorganic elements.
We tested for copper, lead, chromium, aluminum, zinc.
Once we got our data back, which was about 5,000 bits of data, we had to teach them Microsoft Excel so we could make sense of the data. And so the beginning of the report was taking the samples and building surveys and educating the community about the project. And now, which I think is the most challenging part of the project, is taking all that data and making sense of it and putting it together into a report. The purpose of this sharing is so that everyone can take notes on what the findings of each group is up till now. Not every group is done, so they're going to give you their findings as up to now. But we need to make sure that each research group knows the findings of every other research group before we put the report together. If anyone in town comes to you and says, Becca, what did you find as a class, she needs to be able to speak about more than what she and Elena found. So you not only need to take notes, but you need to understand it.
We took 2 topographical maps and divided them into sectors of town. And on one we did the wells locations, and on the other we did the top 20 highest minerals.
After you put the top 20 pins, what patterns did you see?
We didn't really, there was no really pattern that you could see.
There were big clusters of high minerals in
Like here.
sectors.
But what? There were big clusters of pins in certain areas. Why isn't that significant?
Because they weren't the same, they weren't all the same mineral.
Okay, good. So there was a real variation. There was not any one mineral clustered in any one area.
Yeah.
We thought that we would find a really big relationship and and if you had lower pH, you would have higher copper and
And what
lead.
would that look like as a scatter graph?
Well, that.
Can you draw it on the, just to draw it on the chalkboard?
Okay.
Well, if it was
And
pH. it would be
pH there, Cu there.
Yeah, it's copper
Okay,
here.
now if there had been the clear relationship that you thought,
Yeah, it would have looked
what would the
like,
shape be?
It would be like, it would be like this.
Excellent. To do original research means we have no idea what we're going to find. And a lot of our results from this particular study are ones we don't quite understand. For example, we're finding high lead getting into people's water that's been sitting in their pipes in new homes. Now, they're not using lead solder anymore. We have no idea where that lead's coming from. We've contacted a number of people. We don't know what's going on.
We were expecting to find a relationship in sample A because the the water sitting in the copper pipes would have more lead from the soldering.
Okay. I have always been a real fan of trying to come up with projects that evoke passion in kids and that demand some real quality and accuracy. All these levels are higher in A than in B. It's overwhelming. So the high levels of copper are not coming from the ground in Shutesbury. They're absolutely coming from the pipes. Now that's one of the pieces of information that's most important that you be able to share with people in the community. Generally, many schools teach skills out of context. So kids memorize the skills with no endpoint. And so I really like to teach the skills in service of some project that's meaningful to kids. So they're still getting the same basic skills, but they're picking them up in the service of something that's really valuable to them.
Ron's students are planning to share their results through a website and a written report. The report will be distributed to the town government, regional environmental authorities, and the news media.
We could just say, like, what did they find? You know, what was that purple? Barium?
How do we know that kids who leave Shutesbury Elementary School are prepared when they go to the middle school? One way we know is that we get feedback from the middle school. Our students are great readers and writers, and our students know how to problem solve. And that information to me is not only affirming, but it's the best information we could get because it is the engagement with the learning process that we are really seeking to embed in the students. And if you have that, then you can master any particular content.
I never thought that you could have a problem with water. Like, I always figured that the worst thing could happen with water is like it wouldn't taste so good or it would make your bathtub turn green.
It's not just a question of memorizing facts to them. It's a question of doing real research that means something to the world. So I do make sacrifices, and I think I do sacrifice some of the coverage issues, of the memorization issues, and I can only assume that a lot of that stuff you can easily look up, but that you can never look up the understanding of what it's like to be passionately involved in a scientific inquiry.